Arguments and Euler Diagrams. MMW 2122 CPE1A Group 6. Arguments and Euler Diagrams. Many arguments involve sets whose elements are described using the quantifiers all, some, and none. The mathematician Leonhard Euler used diagrams to determine whether arguments that involve quantifiers were valid or invalid. There are some parts of an argument. It is composed of premise and conclusion. Valid arguments. Validity is a crucial concept in critical thinking. A valid argument is one in which the conclusion logically follows from the premises. So an argument is valid if and only if no logically possible situation exists in which the premises are true but the conclusion is false. And it is valid if the fact that all the premises are true forces the conclusion to be true. Invalid arguments. An argument is invalid if it is not valid, which means that even if all the premises are true, the conclusion could still be false. The truth of the premises does not necessarily imply the truth of the conclusion. That's all it takes to declare an argument invalid. Euler diagrams. Euler used diagrams to illustrate logic concepts. Some 100 years later, John Venn extended the use of Euler's diagrams to illustrate many types of mathematics. It is a graphical method that uses circles to represent relationships between classes and operations on proposition terms via inclusion, exclusion, and intersection. Compare Venn diagram. So, Euler diagram is a diagrammatic means of representing sets and their relationships. They are particularly useful for explaining complex hierarchies and overlapping definitions. They are similar to another set diagramming technique, which is Venn diagram. Unlike Venn diagrams, which shows all possible relations between different sets, the Euler diagram shows only relevant relationships. The following figures show Euler diagrams that illustrate the four possible relationships that can exist between two sets. Figure 1 shows that all P's are Q's kasi lahat ng P ay sakop ng Q's. Figure 2 shows that no P's are Q's kasi maghiwalay sila sa isa't isa at hindi sila nagpang-abot. Figure 3 shows that some P's are Q's dahil dito sa part na to. Dahil may part ng P na nasakop ng Q at may part din ng Q na nasakop ng P. That's why some P's are Q's. And last figures shows that some P's are not Q's dahil ang hindi nasakop ng Q ang ibang part ng P. Example 1. Use an Euler diagram to determine the validity of an argument. All college courses are fun, this is our premise 1. This course is a college course, and this is our premise 2 naman. And lastly, our conclusion, this course is fun. Example 1 video. Our premise 1. All college courses are fun. Masaya daw ang lahat ng college courses. Kaya nasa loob ang college courses at sakop ito ng fun. Kasi yun ang nakalagay sa ating premise 1. This course is a college course. Ang course daw na ito ay college course. Kaya nasa loob ang ating course at sakop ito ng college. And lastly, our conclusion. This course is fun. Kaya nasa loob ang course at sakop ng college ang course, while ang fun naman is sakop nito ang college at saka course kasi masaya daw ang course na ito.
And Euler diagrams. Euler diagrams and transitive reasoning. In this part, we will be using Euler diagrams to visually illustrate transitive reasoning. Use an Euler diagram to determine the validity of an argument. Example 4. Use an Euler diagram to determine whether the following argument is valid or invalid. These three are what we call the premises. And this one is the conclusion. All fried foods are greasy. All greasy foods are delicious. All delicious foods are healthy. Therefore, all fried foods are healthy. You might say that these premises are not valid. For instance, the one it says all delicious foods are healthy. But the argument of validity doesn't depend on anything. But if the premises are accepted, then is the conclusion valid or invalid? So let's move on. Here, you can see the Euler's diagram for this argument. It says all fried foods are greasy. So, the fried food circle is completely inside the greasy food circle. All greasy foods are delicious. So, the greasy food circle is completely inside the delicious food circle. All delicious foods are healthy. So, the delicious food circle is completely inside the healthy foods circle. The conclusion for this argument is, therefore, all fried foods are healthy. This dot represents a generic fried food. As long as the dot is in the fried food circle, it will also be in the healthy food circle. So in this argument, we can say that this is valid. Next example. Use an Euler diagram to determine whether the following argument is valid or invalid. Here, the premises are all squares are rhombi. All rhombi are parallelograms. All parallelograms are quadrilaterals. And the conclusion is, therefore, all squares are quadrilaterals. This is an Euler diagram for this argument. It says all squares are rhombi. So the square circle is completely inside the rhombi circle. All rhombi are parallelograms. So the rhombi circle is completely inside the parallelogram circle. All parallelograms are quadrilaterals. So, the parallelogram circle is completely inside the quadrilaterals circle. The conclusion for this argument is, therefore, all squares are quadrilaterals. This dot represents the square. As long as the dot stays in the square circle, it will also be in the quadrilaterals circle. We can say that this argument is valid. Here are another examples to better understand the use of Euler diagram in determining whether an argument is valid or invalid. Here, the premises are all math teachers loves chocolate. Anna loves chocolates. And the conclusion is, therefore, Anna is a math teacher. To better understand this example, let me show you the Euler diagram for this argument. For this one, my two premises are all math teachers love chocolates. Anna loved chocolates. And my conclusion is, therefore, Anna is a math teacher. All of our chocolate lovers go on the outside circle. All math teachers love chocolates, so math teachers live inside the circle of chocolate lovers. That is our first premise. Second premise, Anna loves chocolate. So now, where can we put Anna? She has to be inside the chocolate lover's circle, so she could absolutely be inside the math teacher's circle. But she could also be out here, outside the math teacher's circle and inside the chocolate lover's circle. Anna can live in both places because it is not guaranteed that Anna is a math teacher. Since Anna can live in both places, we could say that this argument is invalid. For the last example, the premises here are all athletes loves energy drink. Sydney loves energy drink. Therefore, the conclusion is Sydney is an athlete. To better understand this example, let me show you the Euler diagram for this argument. For the last example, my two premises are all athletes loves energy drink. Jake loves energy drink. And my conclusion is, therefore, Jake is an athlete. All of our energy drink lovers go on the outside circle. All athletes loves energy drink. So athletes live inside the energy drink lovers circle. So that's our first premise. For the second premise, Jake loves energy drink. Now, where can we put Jake? He has to be inside the energy drink lovers circle, so he could absolutely be inside the athlete's circle. But he could also be out here, outside the athlete's circle and inside the energy drink lovers circle. Jake can be put in both places because it is not guaranteed that Jake is an athlete. Since Jake can live in both places, we can say that this argument is an invalid argument.
and Euler diagrams. Using Euler diagrams to form conclusions. In this part, we will make use of an Euler diagram to determine a valid conclusion for an argument. Example 5. Use an Euler diagram to determine a conclusion for an argument. Use an Euler diagram and all of the premises in the following argument to determine a valid conclusion for the argument. So these two are called premises. The first premise states that all m's are n's, and the second premise states that no n's are p's. So we need to determine a valid conclusion for the argument. So first, let's draw the premise 1. So it says that all m's are n's. So all m's must be inside the n's. So our first premise will look like this. And for the second premise, states that no n's are p's. So the second premise indicates that the set of n's and the set of p's are disjoint sets. So using this diagram now allows us to conclude that no m's are p's. So let's try for another one. Use an Euler diagram and all of the premises in the following argument to determine a valid conclusion for the argument. The first premise, some rabbits are white, and the second premise, all white animals like tomatoes. So we need to determine a valid conclusion for the argument. So let's draw a circle first. This blue circle here indicates the rabbit, and the black circle indicates the white animals. So we have now the first premise, which is some rabbits are white. Let's proceed to the second premise, which states that all white animals like tomatoes. So all white animals must be inside of the circle for the tomatoes. So now that we complete our diagram, we can now conclude for our conclusion. Some rabbits are white, all white animals like tomatoes. Therefore, our conclusion for this argument will be some rabbits like tomatoes.
In showing conditional, we use different ways to show logical arguments, including symbols and Euler diagrams. For instance, we have the sentence, all cats are animals. In an if-then statement, if it's a cat, then it's an animal. This if-then statement is what we call conditional. As a representation of a conditional, we use an arrow. Say for example, C is it's a cat. And then A, it's an animal. In symbolic, C, arrow, A. We use 3 dots to represent the word therefore. In a valid argument, we use the sentences, all cats are animals and Fluffy is a cat. Then, we combine those 2 sentences using the correct order or valid argument. Therefore, Fluffy is an animal. So, the result is true. In the if-then statement or conditional, we turn all cats are animal into a conditional 1. If it is a cat, then it is an animal. And in the second one, it is a cat. And the result is, therefore, it is an animal. Then in symbol, we let C be equal to its cat. Then A is an animal. In symbols, C arrow A. And the second conditional has only one variable, C, its result 2, therefore A. In this example, we use all cats are animals and Dan is an animal. Therefore, Dan is a cat. The result is that the statement Dan is a cat is not true because it was never mentioned that Dan is a cat. It can be a dog or a pig, horse, etc., etc., etc. Using the conditional all cats are animals. If it's a cat, then it is an animal. The conditional of Dan is an animal, it is an animal. We already defined our variables C and A, where C it is a cat and A it is an animal. In the symbol, C arrow A. Below this, we write A. If we combine those two, we get, therefore, C. So, our next topic is valid argument versus invalid argument. The official name for a valid argument is modus ponens. It can also be simply called correct order. The first thing or hypothesis is A. B is the second thing or conclusion. The hypothesis happens true. It was given in the premise that if the first thing happens, B will be the conclusion and must be true. The opposite of a valid argument is an invalid argument, or simply called not the correct order. It is given that if A happens, B must be true. And in an invalid argument, the conclusion in the premise happens. The resulting argument would be therefore A. If this happens, when B happens, it does not mean A must be the conclusion, which makes the argument false. Yun lamang po at maraming salamat.
Hello guys, I'm Alvin Tanagan. I am a student in BSCPE 1A. So, nandito po ako ngayon upang mag-report ng aking ginawang PPT. And our topic for today is about the not symbol in logical arguments. So, ito po ngayon yung aking i-discuss, and then magbibigay po ako ng isang objective tungkol sa topic na ito. So, ang objective sa topic na ito is to present an idea that is both consist and coherent. And ito yung mga arguments in symbolic form. Number 1, consists of a set of statements called premises and conclusion. So, conclusions. So, take note, ang ilalagay dito ay premises, that plural of the word premise. Dun sa number 1, yun ang i-take note. And number 2, can be written in symbolic form using letters. So, this is our topic for today, yung ita-translate yung isang argument statement to a symbolic form. And number 3, considered valid if the conclusion is true whenever all premises are assumed to be true. So, magiging valid lang ang argument statement if the premises are true and the conclusion is true. It considered the whole statement as a valid statement. And number 4, considered invalid if the premises are true and the conclusion is false. So yung number 4 natin, if the given premises are true and the conclusion is false, the statement will be considered an invalid statement. Actually, in arguments, nagbe-base yung validity ng isang argument statement nagbe-base sa premises. Next, the logical arguments. If we want to say it is not a dog, we would use the letter D to mean it is a dog. And we would not symbol in front of it. D means not a dog. The symbol is similar to the complement symbol in. So, ito yung example na nandun sa binigay na topic. Is the following argument valid or invalid? If it's green, then it's not a dog. So this is the premise 1. And the premise 2 is it is green. So ang conclusion natin is therefore it is not a dog. So this example is valid. So next example, if the price of gold rises G, the stock market will fall S. The price of gold did not rise, therefore the stock market did not fall. So yung first sentence, if the price of gold rises, the stock market will fall. So okay, obviously this is an if-then statement or conditional because may if tayong word dito. So sa first premise natin, meron tayong arrow. Yung first na statement dito sa first paragraph. Sabi dito, the price of gold rises G. So G yung ilalagay dito, G. Then the stock market will fall S. So S ang ilalagay dito. So take note, ang G natin is if the price of gold rises. However, dito sa next sentence natin, the price of gold did not rise. Did not. If gumamit tayo ng word na not sa ating statement, it is considered to be a negation. So, anong negation to siya? So, anong letter yung sinisimbolize natin ng negation? So, yung the price of gold rises, i-represent niya yung G. So, ibig sabihin, and the price of gold did not rise, I, the negation of G, letter G. So, ganito yan. Not G. So, itong not G dito is the second premise. Then, over, lagyan ng linyang ganito. Lagyan ng ganyan. Therefore, the stock market did not fall. Di ba yung therefore, ganito, yung 3 dot na ganito. The stock market did not fall. Now take note yung S natin. Kanina, yung S natin, the stock market will fall. Pero dito sa conclusion natin, the stock market did not fall. So, ang kinalabasan niya is negation S. Kasi may word na ginamit dito, did not. So, ito na yung kinalabasan lahat nitong sentence na to. So, next example. All colleges courses are fun. This course is a college course. Therefore, blank is blank. So, itong all college courses are fun. Ito yung tinatawag na premise 1. And then, this course is a college course. Ito naman yung tinatawag na premise 2. And then, itong last na sentence is therefore blank is blank. Ito yung tinatawag na conclusion. So, next. So, by using Euler diagrams, dito sa premise 1, ang sabi dito, all colleges courses are fun. So, ang first below is college course. And then, sabi dito is are fun. Ang all college. So, fun. So, ito na yung kinalabasan ng premise 1. So, first below is called college course. And then, are fun. So, ito yung malagay itong fun. So, next. Premise 2. This course is a college course. So, yung unang bilog is course. Ito yun. And then, yung following bilog is college. Is a college course. So, lahat ng college, ito yun. Ay, lahat ng course is a college course. And then, next, ito yung ganun. Ito yung parang overall. Ay, Euler diagram natin. First, yung course. So, course. Then next is college. And then next is fun. Kasi sabi dito, all college course are fun. So, include atong course dito. So, all college and course are fun. So, kung magsusulat na tayo ng conclusion, therefore, itong course, yung pinakamaliit, ilalagay dito. So, therefore, this course is, so dito, kukunin natin yung dominant. Ang dominant is yung pinakamalaki, so fun. So, ilagay yung fun. So, ito na yung conclusion natin. Therefore, this course is fun.
Okay, good morning everyone. So our chapter for today is Arguments and Euler Diagrams. So before we discuss our topic, may I introduce myself to you. So my name is Jonel Ikusipag. I'm a first year student taking a Bachelor of Science in Computer Engineering, studying at Cagayan State University, Carig Campus. So this chapter was assigned by our professor, Sir Christopher Capili, who is an engineering faculty of COEA. This was assigned for us to fulfill our requirements in his subject, which is mathematics in the modern world. Okay, so let's begin. Objective. The objective of this topic is to prove that the argument is valid. Okay, as you can see on the white screen, I have composed three images, which is square, and followed by the curved line over here, which is called tilde. In mathematics, it is defined as approximately, or it is called, and in logic, it means not. But in our topic for today's discussion, this is similar to, followed by quadrilaterals. So as you can see on the given three images, what did you observe, or what did you guess to this picture? Okay, yes, you're right. Square is similar to quadrilateral, or square is related to quadrilateral. Okay, we move on. Okay, so our subtopic for today's discussion is all relationships and transitivity. So what does this mean? All relationships and transitivity. This is another way of proving that an argument is valid. Okay, in conclusion, as we go on to our topic, as we go deeper, we will be able to understand what does the how this the conclusion impacts the all relationships and transitivity. So in here, all relationships and transitivity, conclusion is tells us about how the squares are related to quadrilaterals. And conclusion, this is always a valid argument. So take note. Okay, we move on. Okay, so first, this is an argument, as you can see on the slides. Okay, so in the premise 1, this is called premise 1, this statement 1. All squares are rectangles. And this premise 2, all rectangles are quadrilaterals. So can I label it? May I label it so that you will understand better. Premise 1. And this is called premise 2. And this last statement, this is a conclusion. Okay, I'm using a mouse. Okay, what we will do next is to determine what is the argument, whether if it's the valid or invalid argument, by using a Euler diagram. So first of all, we need to see the first premise is all squares are rectangles. So the set of squares are rectangles, and the rectangles are quadrilaterals. Okay, so as you can see on my diagram, the squares is related or found at rectangles, inside the rectangles, and the rectangles has been found inside the quadrilaterals. Therefore, all of these squares are quadrilaterals. So all of the given or all of the quantifiers, should I say, has been found in quadrilaterals. So therefore, all squares are quadrilaterals. Nice. And as you can see, if we get the positive, or the result is been found that square is a quadrilaterals. Therefore, yeah, I forgot. So therefore, we can say that this is an valid argument. Okay, and the next, as you can see on the table, in the first column we can see the conditional, and the second column we can see the symbols. On the first row of conditional, and there is if it's square, then it's a rectangle. While on the symbols, S links to R. And on the second row, if it's a rectangle, then it's a quadrilateral. On the symbols, R links to Q. On the third row, the last row, therefore, if it's a square, it's a quadrilateral. Okay, in the symbols, therefore, okay, I forgot to place a comma. Okay, nice. Therefore, comma, S links to Q. Okay, so the symbols in order in the previous slide, should I say, there is a S links to R and R links to Q. So that is S links to R and links to Q. So we can say that S, okay, wait a minute, where's the pen? S is links to Q. So we can say that this is valid argument. Okay, next. An example one. Okay, in the argument, it says that all whole numbers are integers in the premise 1. In the premise 2, all natural numbers are integers. Okay, in the conclusion, therefore, all whole numbers are natural numbers. So how can we say that this is an invalid argument? Okay, by looking at the symbols, W links to I, and N links to I, and therefore W links to N. Okay, to prove it, we will use a Euler diagrams. W is found in I, is linked to I, should I say, and N links to I, in N links to I. Okay, as you can see, W is not chained to N because the N is found over here. So in this scenario, W is supposed to be, in this scenario, W links to I, but but the given is W links to N. So I can say that this is invalid argument. I can prove it, should I say. The next is example 2. Okay, wait a minute. Okay, P links to Q, and A links to B, and A links to R. Therefore, P links to R. Okay, if the is it a valid or not valid argument? Invalid, should I say? Okay, we draw first the P links to Q, followed by A. Oh, I'm sorry. I use si mouse. Mahirap kasi. A links to B and A links to R. Therefore, P links to R. Okay, does the P links to R? Okay, we will see. As you can see on the premise 1, premise 2, and premise 3, the A and B, the A links to B does not have a premise. Wala siyang kaparehas. So, kung wala siyang kaparehas, we can get rid of it. Okay, get rid of A and B. So, ang natira na lang is, allow me to speak in Tagalog, guys. Okay, P links to Q and Q links to R. Which means that P links to R. So, we can say that P links to R. So, this is an valid argument. Dahil nahanap natin siya. Dahil nag-link siya doon kay R. So, this is correct. This is valid argument. Next is example 3. On the premise 1, M links to Z, and premise 2, M links to R, followed by A links to T. Therefore, M links to T. Okay, let's check. M links to Z. Oh, wait a minute. My Z is horrible. Z. M links to R, and A links to T. Therefore, M links to T. Does M links to T? Okay, let's check by using the Euler diagram. We'll use the green one. Okay, M. Sure. Wait. M is links to Z. Oh my goodness. And M links to R. So, dito na lang tayo maglalagay ng R. Wait. This is horrible. M links to Z. Yan. And M links to R. So, R. Between. Dito na siya. M links to R. Di naman pwede dito. And A links to T. A, dito na. A links to T. Okay. Wait. A links to T. Okay, nice. Does M links to T? So, take a look at it. M links to R and Z. So, yung malapit na lang dito, yung nag-link talaga, yung nag-chain is si M at saka si R. So, therefore, in this scenario, it's supposed to be M links to R. But this M links to T. So, I can say that this is an invalid argument. Invalid. Yan na lang. Invalid. Okay. Next one. Or the last page. Last slide, should I say. Okay. The red one. Okay. X links to transpose of Y. So this symbol is transpose or transitivity. This is an transitivity. And transitivity of Y is to Q, and my goodness, this is horrible. Q, oh wait. Q links to M. Therefore, does X links to Q? So take a look, and let's check by using a Euler diagram ulit. Okay. X is links to Y, and transitivity of Y links to Q. and Q links to M. Okay, so take a look at it. X links to Q. Does X links to Q? So we can see that there is a transitivity, or there is a transpose symbol. Okay, symbol like this. Transpose. So you can see on the second premise, we see that there is a transpose here and transpose there. And on the second is we will transpose the Y to Q. Therefore, the Q is will be locate over here. So transpose nga sila, kapalit. Okay, then we can say that X links to Q. So this argument is we can say that this argument is valid because X links to Q. So therefore X links to Q. I think that is the end of our discussion for today.